text,
Yeah. So we have text,
um,
sometimes images, right? And even audio. And I think yes, you have actually defined it well. So it's like a model that is generating an output depending on how you've asked it. I think it's a good definition. You've covered the core aspects of generative AI. So yeah, basically that's it. So generative AI or Gen AI refers to models that create new data from the word generate. It's like creating new information, maybe text, images, code, etc. That is very realistic also. That actually resembles human produced content, especially when it comes to text. When it comes to images, you still have some milestone to work. But then for text, you can actually create a whole novel nowadays using ChatGPT. So they are multimodal if they can process various types of inputs or generate multiple types of outputs. So we have several, when you talk about multimode. So maybe it can process an image. Let's say, for example, ChatGPT. Sometimes you can upload image, you can upload a file, you can generate an image, a file, you can generate text. Like it accepts different types of data. That is when we say it's multimodal. And nowadays, most of them are actually multimodal. So we have several examples. For example, we have text generation. For example, ChatGPT, we do summarization with it. We have code completion, for example, GitHub Copilot. It's like it's predicting what you're trying to code, then it completes your code. Image generation. These are just examples per se. We have like a lot. When it comes to text generation, we have a lot of models doing that. When it comes to code implementation, we also have a lot of models doing that. But these are just examples. Image generation, so for example, stable diffusion. Video generation, for example, Sora. I think nowadays ChatGPT has Sora. um, Music generation, synthetic data generation for training models. So sometimes, I when I remember the site name, I tell you guys. Sometimes when you just want data, if you don't have data and maybe you want data to practice or maybe to train your model, you can either generate your own data. Sometimes you can do it using Python. You can also do it using some sites. Sometimes some sites allow you to just define maybe how many columns you want in data, if you want it to be clean, if you want it to be dirty, the type of data you want, etc. Then it just generates you random data. Yeah, we have like a lot of sites, but I think I should remember one. If I remember, I'll tell you guys. Yeah, so it's also part of generative AI. So they are prompted using natural language. As you've said, it is generating according to what you've asked it. So this is an important part of generative AI, prompting. And they are trained on large data sets. So when you talk about large, we mean large data, because sometimes it feels like they know everything because they have been trained with a lot of data from websites, from books, from research papers, like from different sources, and allows them to learn patterns, relationship, and features within the data. So traditional machine learning is predictive. For example, it can do classification or do some sort of predictions. When you talked about sentiment analysis, you can use traditional machine learning to classify if a comment is positive or negative. Maybe if you're working on maybe a marketing firm, trying to see which reviews you are getting the most and so on. So you can just use traditional ML for that. But now generative AI produces novel outputs learned from patterns. It's more advanced. It is not like, it's not classification anymore. It can do more. It can come up with new data, new tasks, new text, and etc. Yeah. So like all AI, Also, generative AI has its own history. As you've seen, AI is something that started long time ago. It didn't start right now. Maybe right now it's booming, but it's not something that it started like last year or 2 years ago. It started like from 19. People are thinking about machines from 1900, 1920, 1950. And also, I think these instances, like for World War, they also made people think more automation, because there's a lot of invention that came with those world wars. So this is like a combination of evolution of AI generally, plus also generative AI. I know we did sometimes back, we did a history of AI. We talked about the Turing test, we talked about the AI winters and the peaks, and also when we some of the setbacks that we've experienced in the AI space. But now this upper part covers maybe more on the generative AI side. But no, it's I think it's all of it. But I'm not going to read this slide word by word, just trying to illustrate the advancements of what has been happening over the years. But now we can talk more about now OpenAI, because it's like the first generative AI model that made it possible for others to come. That's what I'm going to say. It was like the original, the OG now, but nowadays we have a lot. So in 2015, that's when GPT-1 was released. No, sorry, that's when OpenAI was founded in 2015. And in 2018, that's when the GPT-1 was released. This is just like the model, GPT-1. And then in 2019, GPT-2 was released. And in 2020, that's when we GPT-3 was released, and that's when we started doing ChatGPT. So there's the model, and then there's the part where now we have ChatGPT. So as you can see, it's like a grow. It's like a growth pattern. Like from the word GPT-1, version 1, version 2, more advanced, version 3. Of course, there were some issues like security concerns, like what if people use it to do bad stuff or maybe generate fake news. And I think ChatGPT OpenAI has really worked so much to ensure that AI is kind of safe, because even if right now you prompt chat, tell it, oh, I'm suicidal, it's going to tell you, maybe give you a hotline number where you can call. Then it's going to it's like it is trying not to cause harm. That's what I'm trying to say. You can try texting some bad stuff, but you're going to be banned. So I don't overdo. Yeah, you're going to see those security measures that they have put in place, because releasing such a model to the world can cause harm or good. You know, not everybody is doing things for good. So those are some concerns that they had initially, but they have worked so much on the security aspect. So ChatGPT came in 2020. That's when we forgot how to Google and search for data. And now we had 2022, sorry guys. Yeah, but it was based on GPT-3, the model. And now 2023 we have ChatGPT-4. Of course, between ChatGPT-3 we had ChatGPT-3 mini what, some versions in between. Then we had ChatGPT-4 2023, and I think 2025 we have ChatGPT-5. It's already on, the one that we're using right now. And there's always a lot of improvements. Even you can observe as a user, you can observe a lot of improvements that they have done, a lot of things that maybe ChatGPT-4 could not do. And also ChatGPT-5 has more security features, because people are starting to become too much attached to ChatGPT, and sometimes it's like people develop this emotional connection to, it's a machine, it's AI, it's not somebody, but because maybe it tells you what you need to hear, you have that connection. So it's something that they have worked on when releasing ChatGPT 5. Yeah, so that's just an history for OpenAI. We have like a lot of companies. We have Google, they have Gemini. It started as Bard, it's now Gemini. We have like Claude, we have Perplexity, we have DeepSeek. they all have their own history, but I chose ChatGPT because it's like the most common one. So don't limit yourself to ChatGPT. Honestly, we have a lot of good models out there. Then now this is now a more detailed evolution of generative AI. Also, I'm not going to dig too deep into it because I believe like we did like at least we understand where AI comes from, and also it's a lot of things happening, a lot. But I can just do like a high level explanation. So far, any question? Any comment? Any additional information? Okay, so we can just dive deep into evolution of generative AI. So in the early 1950s, that's why we have like our first early neural network models. The introduction of this algorithm, unsupervised learning for deep learning, and so on. Then in maybe 1990s, neural network models began to emerge, you know. So as we go in early 2000s, we have several advancements. For example, we had generative AI in 2000s, some introduction of transformer-based deep neural networks, autoencoders. Don't worry, we're going to learn more about autoencoders and also more about variational autoencoders and how they differ from, you know, generative AI and so on. So also in um 2010, 2015, 2014, 2018, that period from 2010 onwards, now we have like generative adversarial networks. We have now the GPTs, they started coming up, and now every big tech companies started releasing their own models. I talked about Gemini, we talked about Claude, and so on. So it's been since ChatGPT was released, you can all say like it was like our wake up call, because now every big tech company wants to get ahead. So they start releasing their own models. And some companies like Google, they already have data in their disposal. Like they have all the data. Everything. I think Google has everything. So for them, it's kind of easy to train such a model and they have the resources. So these big tech companies have it easy when it comes to creating these large language models because they have resources, they have data, and everything. And now, 2025 onwards, there's no knowing what we can build with AI. We're still, a lot of things are coming up. Um, we have a lot of even specific models that are specific for specific things. For example, code, other maybe are good for creative, others for talking, etc. So there's always more advancements that are being done in the field of generative AI. So any question or any comment or any concern? So are we together?
Question.
Yes.
I saw somewhere there were people who have built an AI that translates signs, like you know the way the deaf communicate with signs,
Yeah.
the language of the signs.
Mm-hmm.
So, which how did
Come up
they
with that.
incorporate? Yeah,
Mm.
yeah, yeah.
So that should be a combination of computer vision. So one thing you need to know, sometimes you can use several models in a project. Maybe the first model is doing speech translation, another one is doing audio translation, another one can be doing image processing, and so on. So for such a project to be possible, there's an aspect of image processing. So there's a lot of training with video data. You need to train it about sign languages, you know. And then there's also a lot of translation from sign language to maybe English. And this they also now the generation part. So think of it in that perspective. Have I answered your question?
Yes.
Yeah. So when you start maybe handling like let's say end-to-end project can involve incorporating several models that do different tasks, but they at the end of the day, maybe one can do this image detection, image classification. Those are different models, but there's a way when you're doing an end-to-end project, there's a way those models interact with each other and give you the desired output. That's a good project actually. I think I should actually advise you to go and maybe learn more about them. If they have the Git repository, if they have put it out there in public, some people do that. You can go and see which models they have used for different purposes, where they got their data from, and so on. It's going to help you learn more. Okay.
Yes.
Okay. Any other question? So far, I'm hoping we are all in the same page. So we have another concept. I think I mentioned generative adversarial networks when we were doing neural networks, types of neural networks, convolutional neural network, recurrent. Then I mentioned this one, but now it's mostly used for generation. So it's a form of unsupervised learning that was developed in 2014 by an American computer scientist called Ian. So they consist of two neural networks. The one is called a generator and another one is called discriminator. So a generator creates synthetic data by transforming random noise into samples. So it's like it's trying, if it's image, it's trying to generate an image. Let's say if it's cat images, it's trying to generate a cat image. Then a discriminator, it's trying to distinguish between the real image and the fake image. So I think there should be a diagram to explain this one better. So we have the training data that has real samples. Think of it as, I'll use an image example, for example. So let's say this has real cat images. And now the generator is trying to generate cat images. So like they are fake. And now the discriminator is trying to analyze which ones are real, which ones are fake. So in the process of that generation, the generator becomes so good at generating data that is so close to the real samples. And also the discriminator becomes so good at maybe identifying the real one. And it's like a way of training the concept of the whole generative adversarial network is based on that, like generator, discriminator. So see. So the discriminator is trained to distinguish the authentic data from synthetic data. So the two models engage in like a competitive game. It's like I generate, then I tell you, no, this is fake, this is real, this is fake, this is real. So this continuous competitive training setup enables the generator to produce a high quality and realistic output. So at the end of the day, the more data, the more it's trying to generate let's say a cat image, the better it gets at generating a cat image. So at the end of the day, it can even reach a point that it's generating an image that looks like the original image. So I don't know if I hope it's clear. So yeah, let me just repeat because I feel like a lot of confusion. So we have real data. We have a generator that's trying to generate data that looks like the real samples. Then we have a discriminator that is trying to say this one is real, this one is fake. So it's how the whole GAN trains. So the more generator generates, the more the discriminator tries to tell us, no, it's still fake, still looks fake, the better it gets at generating images that look like real samples. So that's how we train. It's like it's a form of a generator, a generative AI. So yeah, that's the end game. Any question on that? So are we together so far? Are we together by the way, guys?
Yes.
I have a question.
Yes.
Is it possible to say that GANs
Mm-hmm.
somehow work similarly to the Turing test?
Yeah, let's say the concept, yeah, the concept is like the same. Maybe the technology is not the same, but the concept kind of the same. But now we see for the Turing test, it was to see if a machine can be like a human being. But now this one, let's say the concept is the same, but now for the uses, Turing test, we wanted to see, can machine be like human beings? Can a machine fool a human being? But now for the generative, we are trying to tell it, we want you to get so good at generating that now become our generative AI. But then yeah, I get the connection. It's
Thank you.
okay, you're welcome. Any other question? So I hope it's safe to assume that you're all on the same page. We have another concept. I think I should explain what is an autoencoder. Then now we can learn more about variational autoencoder. So an autoencoder is a type of neural network that basically does encoding and decoding. So I think yesterday we talked about encoders and decoders. We said an encoder tries to understand maybe a text or data, and a decoder tries to generate. So autoencoder, it's like it is tries to do that. It tries to do encoding and tries to do decoding. Now we have a variational autoencoder now. It's like an advancement for now autoencoder. So it's improved version of autoencoder. So it's tries to generate new data. What do I say? They are deep learning models that probabilistically encode data and compress it within ability, then reconstruct it back. So there's an aspect of trying to encode data, understand the data, then trying to decode the data. So variational autoencoders, just a minute. Okay, sorry for that. So variational autoencoders, they use probability distribution that allows for smooth sampling and interpolation. So I think an example is think of it as an autoencoder. It's like you're trying to learn, I'll still use the cat image. Trying to learn how a cat looks like. That's the encoder part. Then the decoder is trying to see if it can generate how a cat looks like. So it's like that combination. So the decoder, now the generative model, samples from this latent distribution and attempts to reconstruct the original input. So they may create blurrier images than the generative adversarial networks. They are typically used for tasks such as noise reduction from images, data compression, identifying unusual patterns, anomaly detection, and facial recognition. So they are like let's say another type of generative AI. But their generate GANs are better than variational autoencoders. So I think I have a image here that shows comparison between images generated by variational autoencoders and generative adversarial neural network. You can see GAN seem to be like trying to generate something that's more, more improved. Yeah. So that's another example of generative AI. Then now we have transformers. So I think I hinted on transformers also yesterday. It was introduced in 2017 by 8 research scientists working at Google in a paper called Attention is All You Need. So in 2018, Google released PART. This is like the concept which Gemini uses. It's an encoder only model, despite the original transformer, including both encoder and decoders. So we have encoder only models, by the way. We have decoder only models, and then we have encoder decoder models. So yeah. So in 2018, OpenAI so now released now the GPT-1, which GPT now stands for Generative Pre-trained Transformer, GPT. Now we have Chat GPT. So it's Chat Generative Pre-trained Transformer. So which was pre-trained on a lot of data. When you talked about enormous corpora, this is like a lot of data from internet in a self-supervised manner. So remember when we talked about how machines learn. We talked about supervised learning, we talked about semi-supervised learning, supervised learning, reinforcement learning, then we have self-supervised. So ChatGPT uses this mechanism, self-supervised. Transformer models process all tokens in parallel, like simultaneously, and are able to capture long-range dependencies more efficiently. So the self-attention mechanism, where now which transformers are based on, enables the model to capture the significance of every word in a sequence when predicting the subsequent word, thus improving its contextual understanding. So transformers are now the foundation for many powerful generative models and mark major shifts from natural language processing, replacing traditional sequential recurrent neural networks and convolutional neural networks. I want to say like they completely replace them, because when you're still doing a computer vision task, you'll find yourself working with CNNs. But now, these transformers, maybe for some tasks, they may be better. But I think transformers have really performed well when it comes to text generation, voice, audio, and so on. Yeah. Now we have another concept, large language model. So what is a large language model? It's a language model trained with self-supervised machine learning on vast amount of text. Because I think the part that this large language model part is trying to tell us, it's big. A lot of data was involved. You guys, it's a lot of data, like a lot. I can't even imagine. It's a lot. So designed for natural language processing tasks, especially language generation. So it is trained on extremely large data. So some of the sources involved, we have this, it's like an NGO that stores a lot of data. Then we have another one. Then we have Wikipedia. But then we have those controversy theories that say OpenAI, they're still hiding where they get data from, because this is not really convincing enough for us. It's not convincing. Like, it knows a lot, you know. So I think they have like a lot of ways of training their models. Like they have taken a lot of data, but for them, you know, we want accountability. So they just tell us we have used this and this and this. But I think they have used a lot of data, a lot. But this is the ones that they have given us. So it's the one I'm teaching you guys. So so these are some sources of data that they said they used it, because there's also the copyright issue here. So if somebody tells you they have accessed your data without your consent, you're going to sue them. So they have tried to tell us we have used public data. It's openly available for everyone. So we have not violated your rights, your data. We are using, you know, publicly available data. But the way that model is so accurate and knows a lot of things, we are not really convinced, but it is what it is. So more explanation on large language models. So parameters, we said when you're training a model, we have parameters and hyperparameters. So parameters are learned, the things that a model learns for itself. They can be millions, billions of parameters. You don't have to worry about the parameters, because it's what the data contains. So it's like when you're given new information, you learn from that information. You don't know what the information has, but the more you learn, okay, this is important, this is not. It's the same way these models learn. So they learn those parameters from the data. So it's a numerical value. We can say it's a numerical value inside a neural network that determines how model processes input data and generates output. So it's made up of weights and biases. So we said we have the input layer, then we said like a model or an algorithm will assign weights to the data. And then with time, it's going to adjust the weights through processes like gradient descent. And then at the end of the day, we are going to get an accurate output. So it's just the same explanation that we've been learning. This is just an example. Like we have inputs, then we have the weights plus biases, then we have the activation function. This is the bias. Then now the summation, then now the output. Sorry. Weights and bias, we sum them, then we output them, then we take it through an activation function, then now we get the output, then maybe we feed it to the next layer, and so on and so forth. So I know this concept is not like so new to you guys. So we have popular models. We talked a lot about OpenAI, GPT-4, GPT-5 now, right now. So they can do a lot of tasks, a lot. We have Meta AI. Well, their model name is called Llama. I think Llama is open source. This one is not as open source as you think. It is not. Yes, OpenAI has some open source models in Hugging Face, by the way. But the ChatGPTs, the GPT-4, they are not as open source as they claim they are. Yeah. So we have Microsoft with their own Phi 3. It's a transformer model. Llama is a decoder only transformer. We have Google DeepMind, which now the model name is called Gemini. DeepSeek, model name DeepSeek B2, but I think it has several advancements. We have an organization called Baidu with their model name called Annie. XAI. We all know Grok. We have this with their model called Falcon. Mistral AI with their model called Mistral. These are just examples, honestly, because I've just realized every day I'm realizing a new model. Like there's so many. It's kind of overwhelming, by the way. So these are just several examples. You'll find a lot of them out there from different companies, and they have their own strengths and weaknesses. So the more you use them, the more you learn, oh, this is good at this is good at that, and so on. So any questions so far? So are we together, guys?
Yes.
Okay. So okay, because we have large language models, so we also have small language models. They are lighter weight versions of LLMs. They have fewer parameters, which means they can run on maybe lighter devices, maybe on edge devices like phones, um, small devices. Those small devices that use AI, they can run on them. So, for example, okay, they are designs for efficiency, deployment flexibility. Some can run locally without cloud or APIs. They have lower resource needs. As I said, when it comes to neural networks, they are hardware intensive. But then when you design a lighter version, it means that it won't be as hardware intensive as the heavier version. Some can be specialized. Maybe some can be good for coding, good for this, good for being a personal assistant, and so on. So because these are some benefits of small language models, because large language models seem to be more generalized. But now when you have like a small language model that can do a specific task and do it so perfectly, it's more efficient maybe for a business and so on. Then maybe privacy friendly. They don't require constant internet or API calls, especially for the ones that can run offline. So yeah, small language models also exist. So we have several examples also from these big tech companies. Microsoft Phi 3, DeepMind is called Gemma, Llama 3, Tiny Llama, etc. So they are like, it's like a variation for large language models, maybe designed for local deployment, offline deployment, and so on. So now we are talking about generative AI. We've talked about LLMs. But now, how are they able to generate a text? Am I able to ask ChatGPT a question, then it is answering me in a way that makes a lot of sense, and so on. So we have a concept called autoregressive modeling, which you can say it's like the core principle for behind the LLM text generation. So what is autoregressive modeling? Any guesswork? Have you ever like heard of the term? Okay, so basically, let me just read the whole slide, then I'll explain. So text is generated token by token using probability distribution over vocabulary. So autoregressive modeling is like predicting the next word based on the previous ones. I think that's like a simple explanation. So when you talk about auto, it's more like self. Then regressive is like predicting from the past. So in other words, LLM use this autoregressive modeling to create text. So we have an example here. Once upon. So it's like LLM is looking which is the next word as compared to the last. So when I say once upon, which is the better word to accompany that? So I say once upon a. Okay. So I have once upon a. Which looks good to accompany this. Say once upon a time. So it's like it's trying to predict based on the past text. That's why the output makes a lot of sense, because it's okay. Sometimes they do hallucinate to tell you things that don't exist, but mostly it's trying to even if those things don't exist, they still make sense. You can ask chat something that does not exist, it's going to answer you. Maybe you've created something in your head, it's going to answer you. But even if it's answering the wrong thing, it's still making a lot of sense. It's grammatically correct. The story is trying to add up and so on. So they use the concept called autoregressive modeling. So any question? So how is content generated? We have several methods. We have greedy search. If you've done a bit of coding, which I encourage you guys to do more, learn more coding, learn Python. It's going to be easy when you're coding AI. So we have a greedy search algorithm. It's called greedy algorithm because it's like it takes the best output at the moment. So it's almost the same thing. Greedy search picks the highest probability at each step. So a greedy algorithm, if you're familiar with coding, it considers that at that moment, which is the best solution. Then it goes with that solution at that moment. So when you see something called greedy, code wise, it's the same concept. So even for greedy search, it picks the highest probability at each step. It's fast, but it lacks creativity, and it can be used maybe for structured tasks. Then we have beam search. Beam search maintains multiple top candidates and picks the best scoring sequence. So it's like it's trying to analyze which one is best. Maybe I have several prospects. Which one is best? Can be slower, but it's good for summarization and translation. We have temperature. Temperature is like the creativity for how creative do you want it to be. So the higher the temperature, the more creativity can get. The lower the temperature, if you're doing, let's say if you're doing a chatbot, maybe you're using those drag and drop methods. Nowadays you have different ways of doing things that maybe you want code. Sometimes you will need to code, sometimes you won't, which is still okay. So maybe when you're using those drag and drop methods, you'll see a temperature patch. So when you set temperature to 0, it's like telling that model to stick to facts. Don't be creative. Don't try to be creative. Stick to the facts. Yeah. So temperature scales token probability to control randomness. It is fine control over creativity. When it's too high, it is going to produce nonsense. When it's too low, it's going to be dull. It's good for creative writing. Then we have top key sampling. Sampling from only top key tokens. Pros filters out rare irrelevant tokens. Cons, it has limited diversity, and it is best used when you're trying to do a controlled creativity. Then we have top P. Top P, also called nucleus. Samples from smallest token set covering cumulative probability P. So these are different ways in which content is generated. Sometimes it can be a balance of, several methods. Yeah, because as you've seen, both have their own pros and cons. So depending on the task, you can say maybe I want to use several. I need creativity, but I want it to be as quick as possible, etc. So you can use several methods at once depending on the situation. So far, okay, this is just a small image trying to show us several examples. For example, I said if the temperature is low, it's going to be based on facts, no creativity. If the temperature is high, it's going to be more creative. Top 3. So it's like we already have like which are the best scoring candidates. These words. Then now we can pick one from them. And then top P is going to be more on the probability side. And so on. This does a visual interaction to make us understand the concepts better. So any question? Up to there. Are we together?
Yes.
Okay. I'm sorry. So we have another concept called prompt engineering. Actually a good skill, by the way, guys. So because I've said it's a good skill and I know you guys have heard about it, maybe anywhere. What's prompt engineering? In your own words.
Um, to me,
Mm-hmm.
prompt engineering is giving AI
Mm-hmm.
specific details on the type of output you would like guiding it on what you want to see in your output.
Mm-hmm.
Yes.
I think that's, yeah, it's like you're trying to give it some sort of instructions. You're trying to tell it this is what you're expecting. Yeah, that's nice. That's actually prompt engineering. So, mm, if we are to define it maybe scientifically, would say that it's a process of designing and optimizing the input text, maybe the prompt, that give well-crafted instruction to generative AI model to generate accurate, relevant, and useful outputs. So the aim is to get the best desired outcomes from instructions given to generative AI. It's like a way of using Gen AI. So we have generative AI. We have our models with us. but how do you best use them? How do you make sure that you are getting the best answers from our models? It is a skill and practice of designing and refining prompt rooted in natural language processing. So um scientists have sat down and maybe came up with different a concept in which maybe if you design your prompt like this, it's going to be like you're trying to maximize the capabilities of an LLM. Okay, because it's already a generative AI, even if you ask it anything, it's just going to give you an answer. Like anything, it's going to answer. But now how can we get the best answers? How can we get the best output from them? So that's what we call prompt engineering. So there are several guiding principles for good prompts. We have clarity. We're going to go through each one by one. We have clarity, we have context and role assignment, we have step-by-step reasoning, constraints and formatting, examples, etc. So this can be the prompt elements, the persona. So I think the persona is where you're trying to tell an AI, let's say you're writing a CV. So you tell this AI, you are a fresh graduate from this university and you're looking for this type of role and role. So you've already told it, you've given it a persona. You've told it you are a fresh graduate. You know, sometimes when you want chat to explain for you a concept simply, you're telling it, explain like a 5-year-old. You see, like you're giving it a persona. You're a 5-year-old. How do you explain, Then you give it a context. So you are a fresh graduate from this campus. This is your skill. These are your skills. I think the context is the skill part. This is your skill. This is your just a minute. Mm, just a minute. I'll get back. Okay, so apologies for that. So we were talking about prompt elements. So the persona. You are a fresh graduate from this campus. Context. You're looking for this and this type of job. Instruction. I want you to tailor my CV. For example, quantify my achievement. This is the format that I want. These are the constraints. Limit my experience to my skill set. Sound professional. I'm trying to do a whole prompt using the elements. So I'm here. Tone. Sound professional. You know, you set your delimiters, you give it data, the technique, and so on. These are prompt elements, or maybe elements that make up a prompt. So when you talk about clarity, it's be explicit in your instructions to reduce ambiguity, because as you said, these LLMs have been trained with a lot of data. They know a lot of information. So when you don't have a specific or a clear intention, it's going to give you general information. It's not bad, but then sometimes you want a deeper context than just general information. So an example of a poor prompt would be explain machine learning. And now a better prompt would be explain machine learning in simple terms suitable for a high school student with examples of supervised learning. So it's going to explain to you machine learning in the most simple way, provide for you examples, and even in a way that maybe you can even tell it, give me real life examples that I can relate to given my environment. So it's more like getting deeper than being general. So that's the first principle: clarity and specificity. Then the other principle is context and role assignment. So provide context or ask the model to assume a role. There I said you are a fresh graduate, you are this, you are in your first job, you're an intern, and give it a role, give it a role. You are a student. Maybe when you're revising for your semester exam, you can say you're a student at this and this is the final year, this is the context, give it a role. Then give it constraints, some limitation, you know. An example of constraint or formatting would be maybe you're a data scientist explaining the planning to non-technical managers. Summarize in under 150 words, etc. So depending on the prompt that you're, I don't want to say the prompt that you're asking, that's not accurate. Depending on your prompt. Then we have several concepts when you talk about prompt engineering. We have few shot and zero shot prompting. Zero shot is where the model performs the tasks with just the instruction. For example, translate good morning to French. That's like straightforward. Then we have few shot where you provide example. For example, English is thank you, French is merci, merci. I don't know how to talk French. Anyway, so it's like you're giving it an example. So it's like you're trying to tell it, this is what I expect, or think of it in this way, you know. Yeah. Then we have other aspects, for example, step by step reasoning. So encourage logical reasoning by asking the model to think step by step. Encourage chain of thought, trying to tell if it's solving your math problem, you want it to see how have you arrived at this output. So maybe this the first, trying to solve your problem step by step. Then also have another aspect, maybe self-consistency prompting. So maybe ask for multiple reasoning paths, then aggregate. You can tell me, you can tell the model, provide the three different solutions and choose the best one. So I think these methods help you gain the most from a large language model. So sometimes when you're asking, maybe when you're chatting with ChatGPT, you feel like it's deviating from what you want it to do because you've not prompted it as accurate. It's trying to give you general information. Then you're trying to say, no, this is not what I want. Then you're stuck in do this, no, refine this. But if you had given it a good, well detailed prompt, maybe with an example of the expected output, it's going to understand what you're trying to say. Yeah, so today I wanted to do up to prompt engineering so that tomorrow we can start on RAG and agentic AI. Then now we finish our course content and we do our mini project. So any question? Any question, any concerns, any comments? So I'm going to assume that you're all together. Nicole. Hello, Nicole.
Hi.
How is it going?
It's okay so far.
So any
How are you?
question? Mm-hmm.
How are you?
I'm fine, thank you.
Okay.
Okay, so I think I'm just going to assume we are all on the same page. Thank you all for coming to today's class. At least tomorrow we'll have like a shorter session because I see it's only 10 pages remaining, then we finish. And then also if you have any questions, because tomorrow is like the last study day, because Tuesday it's just reviewing the projects, then now we finish up. If you have any questions or anything that has been burning, you can just ask. Yeah, that's all. Thank you all for coming to today's class. Have a good night.
You too.
Thank you.